All right, we're going to continue with lesson 1.3 and we're going to identify the properties of equality. We want to use them because it helps us to solve equations, and that's our ultimate goal for this section, is to solve equations. The first property that we're going to define is the reflexive property. Reflexive property says an expression is always equal to itself. It's like the mirror image. So that means that the left side of the equal sign is identical to the right side of the equal sign. Think of a mirror, okay? So A has to equal A. 5 plus 3 has to equal 5 plus 3. This is the reflexive property. 5 times 3 has to equal 5 times 3. The symmetric property says if two expressions are equal, then it doesn't matter which side of the equal sign you place them on. Equals is equals. If x equals 10, then 10 equals x. In this case, we have if A equals B, then B has to equal A. Equal is equal. If 10 equals A plus 5, then by switching the side of the equal sign that they're on, A plus 5 has to equal 10. That's the symmetric property. It's balanced. It doesn't matter which side of the equal sign they're on, equal is equal. The third property is the transitive property, and I like to think of it as the Dr. Seuss property. So remember, Dr. Seuss had the Cat in the Hat, thing 1, thing 2. They went all the way up to thing 99. We're going to limit it to thing 1, thing 2, and thing 3. So if thing 1 is equal to thing 2, and this same thing 2 equals thing 3, then thing 1 has to equal thing 2. They have to be equal. You have to have at least 3 expressions. So the way you see it defined most often is if A equals B and B equals C, then by default A must also equal C. Okay? It kind of has its roots in substitution, which we're going to talk about in just a second. If 5 plus 3 equals 48 and 48 equals 7p minus 5, then use the transitive property to draw your conclusion. Go ahead and hit pause and then come back and check to see if you got your answer right. All right, so that means that 5p plus 3 has to equal 7p minus 15. Kind of similar to the transitive property is the substitution property. Here what you're doing is you're taking one thing out and replacing it with an equivalent value. So it's kind of like what we do with substitute teachers. I'm not here, so the substitute takes my place. All right. In sports, when a player gets hurt or injured, or is tired, then they take one player out and they substitute another player in, okay? So if A equals B, then B can always replace A. So if 3h minus y equals 16, and we know that y equals 4, then we can say 3h minus 4 has to equal 16 because y equals 4, so we replace it in there. All right, if 6 plus 1 times x equals 21, then we know that 7x has to equal 21. Since we can take 6 plus 1, we know that equals 7, and we can replace 7, substitute 7 in for 6 plus 1. All right, so let's I'm going to do the first 3 with you. I'm going to have you do 4 and 5, and let's just take a minute and go through these expressions and see which property is illustrated. If 3a minus 4 equals b, and b equals a plus 17, then 3a minus 4 equals a plus 17. So, or a plus 17. This is thing 1 equals thing 2 equals thing 3. So therefore, thing 1 has to equal thing 3. So this is the transitive property. If number 2, if 2g minus h equals 62 and h equals 24, then 2g minus 24 equals 62. I've taken out the h and replaced it with 24. Replacement, that's the substitution property. If negative 11a plus 2 equals negative 3, then negative 3a, well, let me back up. If negative 11a plus 2 equals negative 3a, then negative 3a equals negative 11a plus 2. All we've done is switch the sides of the equal sign. So this is the symmetric. Why don't you hit pause and try and do 4 and 5. Okay, so a minus 2 equals a minus 2. That's the identical thing. That's like looking in a mirror. That's the reflexive. If x equals 9, if 9 equals x, then x equals 9. That's symmetric. All right, so go ahead and watch the third part on solving equations. We're almost done.